All right, it seems that the two Renogy batteries that we've been using for almost 3 years to power our off-grid RV are in need of replacement. That doesn't mean they won't work for some functions, but they aren't working for heavy loads. We're just using a car battery tester for 100 amp hour batteries, and this one here is saying that its health is only 26%. It's got 410 crankcase amps, which is low. It's charged at 98%. The internal resistance is high at 7.3 milliohms, and it's rated at 720 amps, but it says replace. And if we go ahead and check the other battery that is from the Renogy series, and we have to make sure that we do the clips on the actual terminal because there's a lot more resistance on these screws here. So I'm doing it there, and we do the quick setup here, quick test, move the amperage to 100 amp hours, and then hit enter. Then we'll see a difference for this battery. This one is showing a health of 39%. It says replace, and it's 503 crankcase amperes, and then the internal resistance is 5.96, so a lot lower than the other one. It's 12.81 volts, and so it's 98% of the charge, but it says replace. Now, that means we're taking it out of the larger parallel bank that we had, but we're reconfiguring the entire system now, and so we have taken our solar panels down and are temporarily storing them in the shed there. Those are 100-watt panels, and we have 10 of them. We're storing them in the shed for now till we reconfigure, and the 4 other batteries, which are the Windy Nations, are now going to be used and put in parallel, which really increases the amperage and can be death amps, because you got 100 amps and you put them in parallel. Now you have 400 amps. We had 600 when we had all 6 batteries in a 12-volt system. That's pretty dangerous. So, but it was working fine. We've had these here for, like I said, we've been using for almost 3 years. These are a little younger, these batteries, than those Renogys. I think these are 2 years old, this system, I think. But I think it actually is that the Renogys we got when we first got married and moved into the smaller RV, and then we got 2 more batteries, which are the Windy Nations, which are probably those 2 there, and then we, about a year and a half ago, we got 2 others. So it's not good to do it the way we've been doing it, piecemealing it, because older batteries degrade in performance and we're discharged deeper. And you never want to discharge deeper than 50%, but that'll half the life of the battery. 30% maybe you'll get, instead of, like, we got 3 years off of these at 50% discharge. And if we go to 30%, maybe we'll get 5, maybe 7 if we're lucky, but 5 probably is the max. We're going to test these, and again, there's internal resistance when you have these posts. So I'm going to take this off and take this off to get a better reading. And when I check this one now, and let's put it there and put this clip here. Now this battery, this one here is going to be, it's turned out when we tested before, this is the weakest. So let's get a record of this one here for us and see what we get. So this is at 62% health. It says it's a good battery. It's 630 crankcase amperes, charged at 98%, 12.6 volts, and internal resistance is 4.76 milliohms. So that's a much lower resistance than the 5.26 of one of those Renogys and the 7 of the other one. So we can try this one again, show the second one that we have in the bank that we're going to use. We're going to make this a 48-volt system when we reconfigure and go for a much lower amperage and a higher voltage, which means we'll be able to use smaller battery cables and smaller cables overall. If you have the money to spend, if you're doing off-grid, you're better off doing 48-volt systems, even though the equipment's more expensive. Makes the batteries last longer, it's less dangerous, makes the run your lines much better, fewer losses. So this is going to be the first time in my life I've gone from a 12-volt system to a 48. Some people go for 24-volt systems because it's easier and lower budget to take 2 strings of 12-volt batteries and put them into 24, but there's not a lot of stuff made for that much anymore. So most off-gridders are doing 48 volts, and we've been stuck in the 12-volt realm for a long time. So we're hoping now to go for the 48 and see how that works. Maybe we'll get another string of batteries when we can afford it, because it'll be about $1,000 for 4 batteries. 42%, that's not good. That says replace. Well, that's weird because it didn't say that before. So that is a weird result. It's showing an internal resistance of 5.77 milliohms and 520 crankcase. That may be something to do with the way that I put this on the terminal. I'm probably getting those washers and the resistance from those washers. So let me turn these a bit better. So don't panic if that happens to you. I do this several times. Isn't any scientific experiment. You want to take the average, and you want to do this as many times as gives you a more reliable figure. So one spot test and say that oh, there's a bad battery, and then you realize that you didn't get good surface area, good contact. So here now it says healthy, 61% health, 627 crankcase amperes, 98% charge. The internal resistance 4.78. So this is now as a good battery. So you just saw it read as a bad battery. Now it's reading as a good battery. That's because these screw lugs and these washers do have an internal resistance, and that's what this device is really reading. It's just reading resistance to the pulse that it's sending out. Now this battery here bulges out, so you'd think it's a bad battery, like something went on and it overheated or something, because it's got this bulge. It's not flat like this one. So let's just check this one out again on video. And here we have, I think, a good contact. And let's see. So now we see 7%. So this is the healthiest, even though it's the one that's bowed out. So far it's the healthiest battery, and it's got 13.9 volts. This one we did top off before, so we went to the float charge. That may be why it's reading so good. 4.56 milliamperes. So that one's good. And then the last one would be here and here. And once again, try to get as good a contact so you don't get a bad battery reading, some spurious bad battery reading. Let's go up to 100 amperes and say enter, and we'll be done with it. But so since these are all testing out good, these are the ones that we're going to put in series for our 48 volt bank. This one says healthy 69%, so this is the best of them all. 663 crankcase amperes. It's at 98% at 12.92, and its internal resistance is the lowest, 4.52 milli. So all these have read out as good. That doesn't mean that those other batteries, when it says replace, they don't have to be away. They're ideal for the RV's 12-volt system, and I will put them in the bottom of the RV where I have my deep cycle backup battery for just the 12 for the lights at night. If everything goes out and the inverter fails, the grid goes down, the inverter fails, you're up a creek, you always have this onboard battery, and I'll put the 2 other ones in parallel with that. Or maybe I won't put them in parallel, Mike. Maybe I'll just keep them in here and use them, because I never drain them in those. It's just a backup for the lights. What do you think? Okay. Go parallel?
You can put them in any configuration that your converter can charge.
Okay.
Remember, now you don't have to worry about the solar charger and everything else.
Right.
You just have to worry about what will the converter do.
Okay.
So any configuration that's acceptable for your converter.
So it could be a 36-volt thing. I could do all 3 of them in series. If it does, yeah.
Data sheet out for the converter.
Yeah.
Whatever it tells you, that's what you can do.
Okay, so right now I'm not doing anything with this battery, but letting the converter do the charging of it. That's that onboard backup that comes with every RV. And I do have some solar panels, and I got a charge controller here, and I was using this to charge these batteries, but I don't want to confuse the converter over there, which is also charging the batteries. So it's one or the other. with this for me, but this does give me the ability to top this off when I want to with the solar. And the solar panels that I'm using for that are these little amorphous silicon ones from Harbor Freight that most RVers will get. They're just 25 watts each, so all 4 of those are just doing 100, as opposed to the monocrystalline panels and the polycrystallines I have that do 100 watts each panel. These are 25 watt panels, and I've got them just going over to that little backup battery on there. So that's our test, and that's how we test it. And I just wanted to ask while I'm videotaping, Mike, for myself, when it shows that these have 620 crankcase amps and these ones have 526 and 470, and it says these are bad, that's monitoring, saying how powerful could these batteries work in a car for that cranking and for that surge.
Cranking it.
And that's what you'd also need if you were trying to power an inverter that was powering some AC loads where there's some, like the refrigerator startup. But these batteries can go for a long time for a 12 volt just running LED lights, right?
Sure.
Yeah.
So what this is saying is, if it told you the state of health was 40%, then what you no longer have 100 amp hours of energy storage capability, you have 40 amp hours of energy storage capability. It's not 0, you have 40 amp hours, right? Now, what you have to be careful of is they tell you to replace it because there's been some degradation in the battery, and most people don't use batteries in isolation. They use them in a system. So a battery that has a state of health that's 40% is going to be very difficult to integrate into a system. It's going to deteriorate the entire system, not just impact its own output. But as its own, or in parallel, those 2 batteries at 40%, they're going to be able to deliver energy, but that energy is limited to what the test condition told you they're capable of doing.
Right. Now these, we saw that 2 of the batteries are 68 and 69% respectively, but the 2 in the beginning are 61, 62%. So that's our limiting factor. When we put them in series, we have to assume that this is going to be acting like a 60% system, right?
That's correct.
Okay.
Yep, that's correct.
And then when we get, if we ever get another string, they'll be starting out at 100%, but since they'll be in parallel with it, it won't affect the overall system.
When the circuits are in parallel, the challenge really is when the batteries are in series to get charge equalization. So given 2 separate circuits, your ability to get equal charges in the batteries in the separate second circuit isn't going to be restricted. It's not going to inhibit that battery bank, right? And since the currents are additive, the performance of that system is going to be the sum of the performance of the individual batteries. So you can use it. I mean, there's no need for them to have all the same internal resistance or they're all the state of health until you start putting them in series.
Right. And here we are putting these in series, so we just know that we're going to be at our least common denominator.
And you're pretty close. I mean,
yeah.
to be honest with you, a 2% difference in the state of health or a 0.1 difference in the charge voltage when they're fully charged is not significant. It's, in fact, the tester is telling you that.
Yeah.
The tester is telling you
still a good battery.
It's a good battery, and you have to assume that good battery means it's a good battery for use in your system.
Yeah. Great.
Okay.
Thank you for that. All right, we'll get back to y'all later on when we continue to reconfigure in this exciting adventure we're doing.